The next operator is a bitwise operator. These operators act on individual bits, which is 0 and 1s. We can use bitwise operator directly on binary numbers or on integer also. So when we use these operators on integers, then the number are converted into a bits, which is a binary number system, and then the bitwise operator act upon those bits, which means that whenever we use a bitwise operator on the integer value, then first we have to convert the integer value into a binary number system, and then we applied a bitwise operator on them. There are 6 types of bitwise operators. So the first operator is a bitwise complement operator. The bitwise complement operator gives the complement form of a given number, which means that if we have a binary form 1 0 and 1 0, then the complement form of the binary number, which is a 0 1 and the 0 1. So which means that the 1s is converted into a zeros and the zeros is converted into the 1s. So bitwise complement operator is just used to complement the given binary number from 1 to 0 and 0 to 1. And in the electronic circuit, whenever we want to complement a given operation, then we use a NOT gate, which gives a complement form of a given binary number. So now let's take a simple example to understand a bitwise complement operator. So here I just opened a Python shell, and now I'm going to implement a simple example of bitwise complement operator. So first we have to know the symbol of the bitwise complement operator. So this is the symbol of the bitwise complement operator. Now I'm going to simply find a bitwise complement operator of a variable x equal to 10. So here we have a x equal to 10, and now I'm going to simply find a bitwise complement operator of this value x. Now here we run this module, we get the result minus 11. So how we get the result minus 11? So now I'm going to explain you how we get a minus 11 result from this x equal to 10 values. So as you see in the example, we have just take a variable x equal to 10, then when we apply a bitwise complement operator, then we get the result minus 11. So here I'm going to prove these values, how we get x equal to 10 to x equal to minus 11. So first we have to convert this x equal to 10 into a binary form. So here we just convert it into the 8-bit binary form. So here this 1 2 4 8 16 32 64 and the last is 128. So this is 2 and this is 8. So 8 plus 2 is 10. And now we are going to convert this binary form into the complement form, which means that the 0 is converted into the 1s and the 1s is converted into the 0. So here we have a complement form of this binary number. So here 0 is 1, 0 is 1, and this 1s is a 0. So here we just create a complement form of the initial binary number. After that we have to just find the 2's complement. So before that we have to see here, when we have a 1 in the last bit, which means that this 1 is a sign bit. So here whenever we have a 1, which means that the values is negative, and whenever we have a 0 at the last bit, which is a sign bit, then the value is positive. So here the sign bit is 1, which means that our answer is just a negative answer. So here I'm just clearly remove this 1 from this whole value, because the last value, or we can say the last bit, is a sign bit. So here we just remove this value and we get the new value, which is 1 1 1 0 1 0 1. So now we have to just find the 2's complement of these values, or we can say these bits. So now we have to find the 2's complement form, which is the 1's complement plus 1. So before that we have to find a 1's complement of these bits, and after that we have just add a 1. So here I'm going to find a 1's complement, which is just similar to the complement form of the binary number. So here, so this 1 is converted into 0, and this 0 is converted into 1s, and the last one is converted into 0. So here we have finally a 1's complement form. After that we have to just add a 1 in the starting bit. So here we just add a 1 here. So when we add these bits, then we get a 2's complement result, which is 1 1 0 1 0 0 0. So these values are the final result. So when we count these values, 1s 2 4 8, 1 plus 2 is 3, and this 8 is 11, and we have already seen here this 1 is a sign bit which is denoted by a negative value. So we have a minus 11 from this whole process. So this is the process to get a complement form of the binary values.